Let us consider the first one. Say f of x is equal to x into mod x. So we can write when x is positive, mod x can be taken as x, and when x is negative, mod x can be taken as minus x. So here we can write x into x, that is x square, whenever x is greater than or equals to 0, and x into mod x will be negative x square when x is less than 0. So mod x into mod x graph, we can say when x is positive, the graph will be x square, and when x is negative, the graph will be negative x square. So we can say this function is continuous in -1 to 1, and also this function is differentiable, that is f dash of x is equal to 2x when x is greater than or equals to 0, and negative 2x when x is less than 0. So f is also differentiable. In -1 to +1. If for x is greater than 0, 2x is positive and negative 2x is negative. So it is not neither increasing nor decreasing. So we cannot say it is strictly increasing. So this function is only differentiable. Now let's consider the second function b. Say g of x is equal to under root of mod of x. And as per the definition of mod x, we can write under root of positive x when x is greater than or equals to 0, under root of negative x when x is less than 0. So here we can see clearly the graph. For x is greater than or equals to 0, we can draw the graph. Root x graph will be this. The graph will be, it's a symmetric graph. So clearly we can say that this function is continuous. Continuous in the interval -1, 1. But this function g is not differentiable at x is equal to 0, because we have at x is equal to 0 there is a corner point where the differentiability is not defined. So that we can say this function, second function, is not differentiable at -1, 1. So not differentiable at x is equal to 0, at least 1 point, so we can go with an option 4. Now let's consider the third function. See, say h of x is equal to x plus square brackets of x, that is greatest integer function or step function, and we know that the greatest integer function which is not continuous at integers, at all integers, because this function is a steps, so this graph is not continuous at all the integers, and hence it is not differentiable, not differentiable at integers. But if you see in the interval other than integers, so x plus step x we can write for x lies between -1 and 0, step x value is equal to -1, so we can write x minus 1, and for x lies between 0 and 1, step x value is 0, so we can write x. So clearly we can see that the slope of these two are positive. Slope of x minus 1, that is h of x is equal to x minus 1, is 1, and slope of h of x is equal to x is also 1. So therefore we can say that h is increasing. H is increasing in both the intervals, that is we can say -1 to 1. So increasing function. So strictly increasing also we can say. So we can go with an option 3. Now let's consider the fourth one. Say p of x is equal to mod of x minus 1 plus mod of x plus 1. So let us consider in the three intervals. Mod of x minus 1 will be taken x minus 1 when x is greater than or equals to 1, or negative of x minus 1 when x is less than 1. Similarly, mod of x plus 1 can be considered to be x plus 1 when x is greater than or equals to minus 1, and x negative of x plus 1 when x is less than minus 1. So here we can write for the interval for x less than minus 1. So mod of x plus 1, mod of x minus 1 we can write it as negative of x minus 1 and negative of x plus 1. And for x lies between minus 1 and plus 1, so mod of x minus 1 we can write it as negative of x minus 1, and here we can write it as plus of x plus 1. And in the third case, when x is greater than 1, so we can consider both are like positive, that is x minus 1 plus of x plus 1. So we can also write the function. So negative x, that is minus 2x, and plus 1 and minus 1 gets cancelled for the interval x is less than minus 1, and here negative x and positive x gets cancelled, and plus 1 that is 2, it's a constant for x lies between minus 1 and plus 1, and for x is greater than 1 we can write here 2x where x is greater than 1. Clearly at x is equal to minus 1, at x is equal to minus 1, here left hand limit extends to minus 1 minus f of x, which is equal to minus 2 into minus 1, which is equal to 2, and limit extends to minus 1 plus f of x, which is equal to 2. Both are same, and even at f of negative 1 also is considered to be 2, because for minus 1 to plus 1, minus 1 to plus 1, when minus 1 is included here, or here 1 is included. So we can say this function is continuous at x is equal to minus 1, and even at x is equal to 0, at x is equal to 0, the function is continuous. F of 0 is equal to 2, and even at x is greater than 1, at x is equal to plus 1 also, we are getting that function is continuous. So clearly f is continuous on interval minus 1 to 1, but it is not differentiable, because here you are getting the left derivative is minus 2 and right derivative is 0, and greater than 1 the derivative is 2. So they are not equal, and hence we can say not differentiable, and they are neither increasing nor decreasing. So we can go with an option only continuous in minus 1 to plus 1. Fourth, D is first option. So finally we can give the answer: A second, B fourth, third 3, and D1, which is option 3.